Hello students, I am Jaya Bhuneshwari, Assistant Professor Physics, Department of Science and Humanities, CK College of Engineering and Technology. In this video, we are going to discuss about the laboratory session for engineering physics. In an university syllabus for physics, we have 5 experiments. First one is the Young's modulus, second one torsion pendulum, third one band gap, fourth one air wedge, and finally ultrasonic interferometer. So in this video, we will start with the torsion pendulum experiment. In the next video, we will see about the Young's modulus experiment. Before going to do the experiment, we should know certain things regarding the torsion pendulum. The first thing we should know what is the aim of the experiment. So this is the aim of the experiment. The aim of the experiment is to determine the moment of inertia of the disc, and hence from that we can calculate the rigidity modulus of the material of the wire using torsion pendulum. Again, for this experiment we need certain requirements, we need some equipments. These are all the apparatus required to do the experiment. First one, torsion pendulum. So it consists of one circular disc, nearly the weight is equal to 1 kg. So the disc is suspended by a thin wire. That wire only we can calculate the rigidity modulus. And then two symmetrical masses we need. Symmetrical means equal. Two equal masses we need. And one stopwatch to know the time period. Screw gauge to measure the radius of the wire, and 1 meter scale to measure the length of the wire. So these are all the things we need to do the experiment, and this is the formula to find out the moment of inertia first, and then from that we can calculate the rigidity modulus. We should know what are all the terms involved in it, where I is the moment of inertia of the disc, m is the mass, two masses we should place on the disc, and d1 is the distance we are going to measure, that is we place the masses very nearer to the screw and measure the distance, let it be d1. Similarly d2, the two masses are placed farthest distance, again we measure the distance, let it be d2. And t0 is the time period without mass. Without placing any masses on the disc, we can calculate the time period for 10 oscillation. From that we can calculate the time period for 1 oscillation, let it be t0. Similarly, we can calculate t1 and t2. So t1 with mass closest distance and t2 with mass farthest distance, and L is the length of the pendulum and R is the radius of the wire. Okay, so that's all about the formula. And before going to do the experiment, we should know some theory part also. What is the modulus of elasticity? Already we learned in the theory part. Modulus of elasticity is nothing but is a ratio between stress and strain. Hope you understand what is stress and strain. So rigidity modulus is nothing but a shearing stress by shearing strain. So in modulus we have three types of modulus. One is Young's modulus, second one rigidity modulus, and third one is the bulk modulus. So in torsion pendulum we are going to find out the rigidity modulus. So rigidity modulus is nothing but shearing stress and shearing strain. Here the angle involved, that is rigidity modulus. And shearing stress is nothing but a shearing force by area. And shearing strain, it is nothing but theta, it is the angular deformation produced on the body. In terms of theta, we can calculate the strain. And inertia, since first we calculate the inertia, then only we can calculate the rigidity modulus. So we should know what is inertia. Inertia is nothing but a tendency to do nothing or to remain unchanged. That is the inability of the body to change itself from one position to another position. That is called inertia. And moment of inertia, the force come into act to take a movement, that is called moment of inertia. So it is a physical quantity which describes how easily a body can rotate about a given axis. The general formula is I is equal to mr square, where m is the mass and r is the radius of gyration. So these prerequisites you need to understand the concept and do the experiment. So what is torsional oscillation? By seeing this small animation you can understand easily. See this animation. So this is torsional oscillation, not completely one rotation, full rotation. It with the one axis it rotates to and fro. So this is called torsional oscillations. In torsion pendulum also we twist this wire and then the disc rotate like this, to and fro oscillate like this. From this we can calculate the time periods. Okay, hope you understand the torsional oscillations. And what is rigidity modulus? Rigidity modulus is nothing but this is the original position of some object. If we give the force in this direction, what happens? The shape of the object itself changed. So in between these two, one angle is formed. So in terms of length, we can measure the theta. So by seeing this small animation, you can understand this concept also very easily. See this one. So this is the original shape. After giving the force, it changed to this kind of shape, and one angle is created in between these two. Again, if the force is removed, it goes back to the original position. So this is about the rigidity modulus. And why we calculate the rigidity modulus and what is the importance to calculate the rigidity modulus? So these are all the applications of rigidity modulus. So using rigidity modulus, we can measure of how rigid a body is. That is, we can easily analyze whether a body is rigid or very soft. And also it is used to analyze the mechanical properties of the solid. So the different mechanical properties having different applications. So by measuring rigidity modulus, we can easily analyze the mechanical properties of different types of solids. So this is also one important applications of rigidity modulus. And also we can determine how elastic or bendable, again how much of elasticity it has, or otherwise how much stiffness it has, we can easily calculate by measuring the rigidity modulus. So in many calculations we use the rigidity modulus. In many applications we are using the rigidity modulus. So these are all the applications of rigidity modulus. So this is the need to calculate the rigidity modulus. Okay, now we will move to the experimental part. So in this laboratory session, we are going to discuss how to determine the rigidity modulus and moment of inertia using torsion pendulum. So this is the torsion pendulum experimental setup. In this, it consists of one thin wire. This thin wire only we have to find out the rigidity modulus. So this thin wire is attached one disc at the bottom, some heavy disc around its weight is nearly 1 kg. So in between we have two screws. So in this wire we have to find out the rigidity modulus, and we have to find out the moment of inertia of this disc. So first thing we have to do is, first we measure the distance between these screws. It gives the length of the pendulum. Likewise we place this, and up to that, what is the reading? It is around 70 centimeter. So 70 centimeter is the length of the pendulum. We should note it, L is equal to 70 centimeter. And to start with the experiment, first you rest the pendulum. So in this, it consists of 3 parts. 3 readings we are going to take. First one, without placing any mass, we have to note the time period for 10 oscillation. From that we can calculate the time period for 1 oscillation. This is the first part. And second part, we have to place 2 equal masses like this, and then the same procedure, 10 oscillation, note the time period for 10 oscillation. From that time period for 1 oscillation, it gives the T1 value. Again you place the masses like this, do the same procedure, find out the time period for 10 oscillation. From that we can find out the time period of 1 oscillation. It gives the time period T2. So from this we can measure 3 readings, T0, T1 and T2. So first we will do without placing any mass like this. First you keep this point in your mind, right? This black, right? This point you keep it in mind. Slightly rotate or twist the wire. Not the pendulum, you just twist the wire like this. When this part comes here, you start the stopwatch, right? When this end again comes to this end, you count it as 1. Now 1 oscillation completed. The second oscillation started. This end goes here. When it comes to the same point, now 2 oscillations completed. So likewise you have to count 10 oscillations, and finally after the 10th oscillation you just stop the stopwatch and note the reading. So it gives the 10 oscillation time. From that you can find out the 1 oscillation time. So first part over. Again you reset the watch and place 2 masses like this. And first you measure the distance between these two centers. Divided by 2, it gives the D1, distance D1. Right? Measure the distance and divided by 2, it gives the D1 distance. Again you first rest the pendulum and likewise you twisted. When this end comes here, you start the stopwatch. Right. I started here. So this end when comes to here, I count it as 1. So 1 oscillation completed. So the second oscillation started. When again come to this end, you count it as 2. Likewise, you have to count for 10 oscillation. After the 10th oscillation, you stop the stopwatch, note the reading. So it gives the time period T1. So the second part over, again you reset the stopwatch. Place 2 masses at the extreme end like this. Measure the distance between these two centers and divided by 2, it gives the distance D2. The procedure is same. Likewise, you twist the pendulum. When this black end comes here, you start the stopwatch. I started. When this end again comes to here, you count it as 1. See, this end comes here. So 1 oscillation completed. The second oscillation going on. When this end comes to here, second oscillation completed. Now the third oscillation starts. Likewise, you have to count for 10 oscillation and finally we get the time period T2 from this. Again, stop the stopwatch and reset. Okay, so 3 parts over. Using this, we can find out what is T0, T1 and T2. One more portion is we have to find out, that is we have to find out the radius of this wire using the screw gauge. So this is the screw gauge. Before going to take the readings, you have to find out the error and correction. So in screw gauge, if these two lines exactly coincide with each other, that is 0 and this line exactly coincide with each other after completing the complete screws. Okay, if it is like this, then no error. But if I tighten the screw, what happens? The 0 either it goes up or down. So there is an error in the screw gauge. See, this 0 is somewhat here in the upper portion, right? So if 0 lies above this line, it is a negative error. Suppose 0 lies like this, it is a positive error. So according to the screw gauge, we have to find out the error first, and depending upon the error, we have to find out the correction also. After doing this, you fix the screw gauge at the wire at some particular place, any place. You tighten the screw and note the pitch scale reading and head scale reading. So pitch scale, it's a very thin wire, so pitch scale reading almost 0 only, and exactly up this line you find out the head scale reading, right? Likewise, you have to fix it some 2 or 3 places and find out the pitch scale reading and head scale reading, right? Like this, 3 or 4 places, fix it and find the pitch scale reading and head scale reading. So all the readings are tabulated in a tabular column. Okay, so this is the procedure part, how to do the experiment. Now we will move on to the calculation part, how to calculate the moment of inertia and the rigidity modulus. We will see in the calculation part. Hello students, now we are going to do the calculation part. So to find out the moment of inertia and rigidity modulus using the torsion pendulum. So the first part is to find out the time period, and this is the tabular column to find out the time period. So first one, without mass, we have to oscillate the pendulum 10 oscillations and find out the time period for 10 oscillation. It's around 137. This is trial 1. The same thing we have to do in the trial 2 also. It comes around 135. Take the average, it comes around 136. From this we can find out what is the time period for one oscillation, that is divided by 10 we get the answer. This is T0. What is T1? T1 with the masses we have to calculate the time period, the same procedure. So 10 oscillation we get the time period like this. The same thing we get for the trial 2 also, the average is the same. So dividing by 10 we get 13.9 for T1. And D1 I already told in that video. So measure the distance between the centers of the mass divided by 2, we get the D1. See, it's around 2 centimeters, 2 into 10 power minus 2 meters. So this is D1. And coming to the third part, T2. How to calculate T2? With the mass distance apart. This is very closest distance and this is distance apart. In this we get 148 trial 1, again 148 trial 2, and average 148 divided by 10, 14.8. Again find out the distance D2, find out the distance between two centers divided by 2, we get 4. So D1 2 and D2 4. Now this is a tabular column to find out the radius of the wire using screw gauge. So first of all we should measure the zero error and zero correction. So this is the zero error and this is the zero correction. So the zero, if the zero lies above the reference line, we get the negative error. Correspondingly we get the correction plus 0.05. And we fix the screw gauge at some 4 or 5 points. Take the PSR reading and HSC reading. So first reading 0.441 and 0.42, 0.41, 0.43. And observed reading is nothing but PSR plus HSC into least count. Do this calculation, you get 0.41, 0.42, 0.41, 0.43. Again corrected reading how to get? You have to plus or minus from this reading depending upon the error and the correction. Now we get the error negative, correction in positive. So you have to add 0.05 to every reading. Here we have 0.41, adding 0.05 we get 46. Likewise adding 0.5 every reading you get this answer. Take the average, it gives the diameter of the wire. But we have to find out the radius, right? So radius 0.467 divided by 2 we get 0.23 into 10 power minus 2 meters. So two tabular columns we filled all the readings. This is the formula to find out the moment of inertia. So 2m d2 square minus d1 square t0 square divided by t2 square minus d1 square. So substituting all these terms we get I. This is the formula for rigidity modulus. First we will calculate the moment of inertia. So m is nothing but 100. We place 100 grams on each side. So this is the mass. D1 around 2.5 and D2 5 and T0 13.6, T1 13.9 and T2 14.8. And substituting all the terms, for 100 you put one minus 3 here, and for distance you have to put minus 2 here, minus 2 here. Since it is in centimeter you have to convert it into meter. And 13.6 is the T0 value, this is T2 and T1. So substituting everything in the numerator comes around like this. So the power comes minus 7. How comes minus 7? Here minus 3. If you square this one you get minus 4. So minus 4 minus 3 you get minus 7 here. Squaring these two and subtracting you get this answer. So dividing these two you get this answer. Something you have to rearrange it. You bring the answer into 10 power minus 4. So this answer comes like this, 17.185 into 10 power minus 4. So this is the I value. Now we can calculate the moment of inertia. Now we will see the calculation for rigidity modulus, and this is the formula for rigidity modulus, n equal to 8 pi IL r power 4 t square. So 8 is a number, pi we have to substitute 3.14, and I is the moment of inertia. Already we have find out it is around 17.185 into 10 power minus 4. L is the length of the pendulum. Initially we measured the length, it is around 70 centimeter. And R is the radius of the wire. We can calculate it by using screw gauge. T is the time period without any masses. So this is the values, and substitute all the things. 8 into 3.14, 17.185 into 10 power minus 4, 70 into 10 power minus 4 divided by t square. So that this is R value 0.23 into 10 power minus 3 to the power 4, and this is the t square. So that I will put 2 times. Since it is a t square, I put 2 times, and multiplying all the things you get this value into 10 power minus 6. Since you have 4 here and minus 2 here, so totally we get minus 6. In the denominator 3, here 4, multiplying these two you get minus 12. So this you take into the numerator, dividing these two terms you get this one. 10 power minus 6 already is there. This 10 power 12 you bring it to the numerator, so that it converted into plus 12. So rearranging these two you get 10 power 6, and rearranging again 5.8 into 10 power 10 is the final answer. So rigidity modulus N equal to 5.8 into 10 power 10 Newton per meter square. Finally, you have to write the result. The moment of inertia of the disc equal to 17.185 into 10 power minus 4 kg meter square, and rigidity modulus of the wire N equal to 5.8 into 10 power 10 Newton per meter square. Thank you. Thank you for watching the video.